Chapter 5, Section 5. So we're going to look at some more formulas for trig functions. We're going to start with this warm-up problem, which will help you see how some are created. So if we look at 2x, 2x we split up as x plus x in basic algebra. So if we have sine 2x, we can rewrite this as the sine of x plus x. And so now we have the sum of two angles. So if we use that formula from before, it's sine x cosine x plus cosine x sine x using our identities from 5-4. Now those are the same thing, so it's the sum of two like terms that can be written as 2 times sine x cosine x, which is one of our formulas for today. And so you can see how we can derive or come up with new identities from old ones in some basic algebra. So we're going to be using double half angle power reducing. We are not going to do these last two. We're going to assume that in the future you can apply the same kind of logic to those, and we're going to just hammer out those first three. So double angle formula. So the sine of 2u is the one we just talked about. It can be written as 2 sine u cosine u. So we kind of derived that one already. The cosine of 2u actually has three options. You have some choices. You can write it with the cosine and sine. You can write it with just the cosine. You can write it with just the sine. And so really what else is in the problem where you're using for tells you which of these you're going to choose. And then the tangent again uses a quotient similar to the previous ones we talked about. So you have the sine of u is equal to 3/5, and we're in the first quadrant. And so if I make that triangle, sort of first quadrant, and u, this angle, opposite over hypotenuse, it's a 3, 4, 5 triangle. So then I know the cosine of u has to be 4/5. And that'll help me write out these trig functions. So sine of 2u is 2, the sine of u, which is 3/5, cosine of u, which is 4/5. So when you're writing that, the formula, you rewrite the sine of u and cosine u as their ratios, which then allows you to simplify this. So this is 2 times, and 3/5 times 4/5 is just going to be 12/25, which is 24/25. And so this would be the ratio for the sine of 2u. Cosine of 2u. Now for this one, now that we know both sine and cosine for u, we could use the first one or any of these three, but since we are only given the sine of u, if that was the given information, and the only problem I asked you to do was cosine 2u, I would not have to find the cosine u if I chose this last one right here, because it only uses sine u. So since we're given sine u, let's use this last formula so you don't have to deal with some unknown trig ratios. Now we already did find it with this triangle for cosine, but we don't need to for here. So sine squared u, well the sine of u is the 3/5, and then we're going to square it. So notice how when you're dealing with these formulas and you have to square the sine or cosine, you first write the ratio 3/5 and you square that ratio. So this would be 1 minus double this power, this fraction squared, so it would be 9/25. Or this is 1 minus 18/25, which is 7/25. So that's the cosine of 2u. The tangent of 2u, then, we do need to find the tangent of u in the formula here. So the tangent of u, back to my triangle, is 3/4. So this is 2 times 3/4. 1 minus tangent of u, which again is 3/4, and then that quantity squared. So our numerator, I can reduce this 2 and 4 to make 3/2. Our denominator is going to be 1 minus 9/16. So this is the same thing as 3/2 over, and then 1 minus 9/16 is 7/16. And then instead of dividing by the fraction, I'm going to multiply by the reciprocal, which then allows me to reduce if the 2 goes into 16 8 times. So then I'm going to get 24/7. That would be the final ratio for the tangent of double the angle u. So those would be the three ratios. Okay, so now we can solve some using some of these formulas. So cosine of double x. So we cannot deal with the solving when you have cosine 2x and the cosine x. Those are different, and so you can't use it the factor. You can't pull out cosine x because it's not cosine x, it's cosine 2x. We first need to change cosine 2x using our formulas. So if we go back to our formulas, let's first know we have cosine x in the problem. So we go back to our formulas. Notice how this one right here only uses cosine, and that's the one we're going to use. So cosine 2x is the same thing as 2 cosine squared x minus 1. You can see that from the formula sheet. And we still have plus cosine x. So because I chose this formula, I kept everything in the equation as cosine x. If I use the other ones, I would be bringing in sine x, and then we have to use more identities to change them again. So here I'm going to rewrite the trinomial. So I put the negative 1 last, so you can see the trinomial, which then becomes factorable. So we have 2 cosine x and cosine x. And we're going to have a negative 1 and positive 1. And that will give us an y value that's positive 1. So we can set each of these equal to 0. So we get 1/2 and negative 1. So 1/2, that would be pi thirds plus 2 pi n, and 5 pi thirds plus 2 pi n. And then cosine x equals negative 1, that would be at pi plus 2 pi n. So it would be the 3 spots in one unit circle, or these would be the infinite amount of answers for x. So this power reducing, I'm going to skip that actually. Half angle. So we're looking at evaluating some angle. So evaluate the exact value of cosine of 105 degrees. And that's not on the unit circle. So we want the exact value, but it's not on the unit circle, so how do you do that? We want this quantity, the quantity of this angle, cosine of this angle, to be equal to 105. So if we want cosine of x divided by 2 to equal the cosine of 105, what does x need to be? So we can write that as cosine of 210 divided by 2, because that's equal to 105. 210 is down here. It's actually 30 degrees past 180. So that's actually on the unit circle. And so using the formula for that, it's plus or minus the square root of 1 plus cosine of just the numerator, 210. So now we'll be able to rewrite cosine of 210 over 2 using the exact values of cosine 210. Yes? What is it?
I don't know.
I don't know, but it's broken from whatever it's from. Maybe from your stroller. We'll see if a part's broken off your stroller. And so cosine, this is really 105, equals plus or minus the square root of 1 plus cosine of 210. So cosine is the x value. That's the negative root 3 over 2, all over 2. The whole thing's being rooted here. Now, we do not want the fraction within the fraction. So what we are going to do is we're going to multiply the top and bottom, I'll do it up here, the top and bottom by 2 over 2. So put that in parentheses. So if we do that, you get 2.
Daddy, maybe.
So we distribute the 2. So we distribute the 2 with 2 plus the negative root 3 all over 4, which we plus or minus the square root on the numerator is 2 minus root 3. The denominator we now write as 2 because the square root of 4 is 2. The last thing we need to do here is to figure out what sine it actually is. Cosine of 105, where is this angle? Cosine of 105 is up here. All students take calc. Sine is the only one that's positive here, so we actually need the negative value. Okay, so then our final answer will be negative root 2 minus root 3 all over. So this is the final exact ratio because we're leaving it in radical form. Okay, let's solve this one, and notice how we have cosine and sines. We have to deal with changing the same function. We have them squared. We also have x over 2, so this is a half angle. So I would look at the sine squared of x halves and try writing that again using the formula for the half angle. So I want to put the square on the outside because this is really the half angle sine being squared. So I'm putting the square on the outside. Then the sine of the half angle, back to our formulas here, is this one right here. So you have plus or minus root 1 minus cosine over 2. So plus or minus root 1 minus cosine x over 2. Notice how we changed it so now it's all cosine x. That's kind of nice. So now we have cosine squared x equals, and then if we square this, when we square this side, a positive squared is positive, a negative squared is still positive, so you get rid of the positive and negative, and the square root squared goes away. So we just get the 1 minus cosine x over 2. So now we can go through our solving technique. Let's multiply both sides by 2. So those are gone. And then I'm going to add my cosine x. I'll add the cosine x to both sides. Subtract the 1 to both sides. So we have this side equals 0. So now we can factor this, which should look quite familiar to a previous problem we've already done today. So we want a positive 1, negative 1, and so we actually get the same exact answers as the previous solving problem because cosine equals the same two values. We have the pi thirds plus 2 pi n, the 5 pi thirds plus 2 pi n, and then the pi plus 2 pi n. Those are all the possible solutions. Product to sum, again, these are formulas that if you're given the formulas, you should be able to manipulate them and to help you out. But we're not going to go into a lot of problems this year on those. We're going to stick with just the ones we did. We're going to look at the half angle formulas, and we're going to look at the double angle formulas. We're only going to stick with those. The double and half. So I've actually got rid of the power reducing as well. So just those two for 5-5 is all we're going to focus on this year. Call it good. Have a good night. We'll see you tomorrow.